Okay, I'm going to start a daily process here, and this is going to be Functions 11, and I'm using the Nelson textbook, but keep in mind, even if you're using the other McGraw textbook, the questions are very similar, so the methods in here are useful. And this is not to give you answers to your homework. This is to show you how, especially for young people who don't have someone to help them at home, is to show you how to do the questions. Now, I strongly recommend, if you want to improve your mark, watch some of my videos on notebook taking, because how you take notes and how you study is very important. For instance, they found that writing things down improves your memory. And they also found that if you're rested and well fed, it improves your results. So never sacrifice those two things. I would also strongly suggest, especially university, open your textbook on the first day, find out how many chapters there are, and more importantly, how many sections. For instance, here, Chapter 1 has 8 sections. Generally speaking, they're all going to have 7 to 8. And as we look, we can see that there are a total of 8 chapters. Well, 8 times 7 is 56. 8 times 8 is 64. So you're going to have somewhere, 56 and 64. So you're going to have somewhere in between that number of sections. That means you have to space out your time accordingly. So if you have a 56-week course, you need to cover a section a week. And the longer you wait, the worse that gets. It's much easier to study 20 minutes a day than it is 5 hours before the exam, especially math. So here's my other tip. Math is about practice. It's not about reading, not about listening, it's about practice. So do as many of the questions as you can. And you'll see in the first section, they calls the skills and concepts. They bring you back up to speed on things that you should have had up to speed before. But I will also try to cover the skills and concepts. So this is all about expansion. Okay, so this 3 is right beside the bracket, and this bracket has 2 things added, and this bracket has 2 things added. So we're going to expect 4 things added or subtracted when we're done. Okay, so I'm going to just grab the first 4. And these are all useful. Skills. And so let's look at just one at a time, because they all follow this method. And this one's good because the 5 after is a minus 5. By the way, never study on your phone. Always have a workstation. Turn off your phone and focus. Half an hour of study, take a break. Half an hour of study, take a break. So this means the 3 is going to multiply the x and the y. Since they're all plus, it's all going to come out as pluses. So 3 times x and 3 times y. And then we're going to have a minus here, and it might be a minus, it might change to a plus. But we can almost skip this and just focus on this part of it. Well, minus 5, and what's this x? It's a plus. Whenever you don't see it, there's a plus. So minus 5 times plus x is minus 5x, but a minus times a minus is a plus. So always keep in mind, in addition or subtraction, if the 2 signs are the same beside each other, it's going to end up a plus. If the 2 signs are different beside each other, it's going to end up a minus. So that's the simple rule. So all you have to really remember is when they're the same, it's a plus, and the other situation will be a minus. So minus 5 times x is minus 5x, and minus 5 times minus y is plus 5. So you get this. And then what you want to do, and when everything's plus and minus, you're allowed to move it around any way you want. But what you want to do is find like terms. And like terms are things with an x and a y. As long as they don't have an exponent over them, they can be added. So we can see when I rearrange it, I've put the like terms beside each other. And 3x minus 5. So it's clear 5 is bigger than 3, and 5 is a minus. So we're going to end up in minus territory. And then after that, a little trick is just take 5 minus 3. It's 2. So we're going to end up at minus 2x. If not, practice the number line. And then over here, plus 3y plus 5y is plus 8y. Since we don't know y and x anymore, or any more information, that's as far as we can take it. And that's how you expand and group. What do you do in a situation like this? Well, you can expand it out for sure. And if there was a left side of the equation or a right side of the equation, let's say it was equal to 5, I'll let you in on a secret. Whatever you do to the right side of an equation, if you do the exact same thing to the left side, will not change the equation. So what you would normally do is put this whole thing in a bracket and multiply it by 2 on both sides. And that would get rid of the bottom. Now, as it is, we can't do that. So we just realize it's half times x squared plus a half minus 3 halves x squared plus 3 over 2. So you end up with this. And I'm not going to do the fractions properly. So half x squared plus a half minus 3 half x squared minus plus 3 half. And that became plus 3 half because it's minus 3 half times a minus 1. Don't worry, when we get more into it, I'm going to go into more detail. But for warm-up, I expect you to have some skills from last year. You should improve your knowledge of how to add fractions as well. You can only add fractions that have the same terms. So a half plus 3 1/2, or 3 halves, is 4 halves, or 2. So this whole thing is going to become plus 2. And over left, a half minus 3 half. Well, if I take a half away from one of them, I'm left with minus 2 over 2, which is 1. So I'm left with minus x squared plus 2. And generally, you put the x terms first, and then the numbers after. So that would be the answer to that. Okay, what about, I'm going to skip the others. The others are pretty much the same. And then they want you to go back and plug in. They want you to put an x and 3. Wherever you see an x, replace it with 3. And wherever you see a y, replace it with minus 5. And you can either do that at the simplified stage or even at this stage. But doing it at this stage will take longer. Solve each. So I'm going to give this as an example. And actually, that's probably not a great one. Let's do this one as an example. What does 4 have? I'm going to keep them both, actually. What does 4 have in common with 3 on the left? Well, when in doubt, you can just multiply them each together. It won't ever always give you the lowest common denominator, but it'll come close. In this case, it is indeed 12. So as I said, I'm going to put everything in the right in brackets, and I'm going to move the other side to the side. I'm going to put it in brackets, and excuse my shaky brackets. And I'm going to multiply it by 12 as well. Now, when you're multiplying something, even though the top is a minus and bottom, and normally you would have to multiply it by each thing, this whole thing up top is being divided by 4 and then multiplied by 12, which means I can cancel out right here. And 4 goes into 12 3 times. And over here, 3 goes into 12 4 times. This effectively gets rid of the bottom denominator, gets rid of my denominators entirely and my brackets. So I can just do that. And replaces the 12 on the left side with a 3, because the 4 went into it, and on the right side with a 4, because the 3 went into it. Now I can distribute as normal. 3 times x, 3 times minus 2, plus 3, by the way, is equal to 4 times 2x, 4 times plus 1. Notice they're all adding and subtracting. Now, I would want to get all my x's to one side. It does matter to make it easier. It would actually be smarter to get my 3x to this side, because then I don't have any minus x's, but it won't matter. So I'm going to get my x to the other side, because they're all adding and subtracting. I'm going to subtract 8x from both sides, and it's clear that disappears. Then I want to get rid of that 6 on the left side by adding 6 to both sides. And as I said, whenever you do the same thing to both sides, you're actually not changing it. You're just rearranging it. Plus 6 plus 4 is 10. What's minus 3x minus 8x? Well, the 8 is the bigger number, and it's minus, so we're going to end up in minus territory. And 8 minus 3 is 5, so we're going to end up with minus 5x is equal to 10. When I divide both sides by minus 5, I'm left with x is equal to 10 divided by minus 5, which is minus 2. And that's how you would solve that. So it's always easier to get rid of fractions by multiplying the left side and the right side by a common term. In this case, notice that there's 2 terms on the left. So you just put a bracket around both of them. And the number in common with 4 and 6 here is 24. So I'm going to multiply it by 24. And that ends up being the same as this. 24 times this term and 24 times this term, and the minus is associated with this term. So it ends up being this. So that's a plus 24 because we can't see it. And just remember that if things are adding in the bracket or subtracting in the bracket, we should end up with two terms that are adding and subtracting. And just associate the minus with the 3. Okay, it's clear here the 6 goes into 24 4 times, and 4 times 5 is 20. 20y. The y is actually, up top. Same thing over here. If we put this in brackets, the 4 goes into 24 6 times, and 6 times minus 3 is minus 18. So we get minus 18, and don't forget there's a y there. And all of it is equal to minus 3. But remember, we have to multiply both sides by 24. So that's something I forgot over here. And so minus 3 times 24 becomes minus 72. Which means we're left with this. So I'm going to try to make it bigger. Obviously, I get 2y on the left. Divide both sides by 2, and I get that. And that's how you solve those. Graph. So how do you graph something? Well, there's something called a t-table. And here's how it works. So just make on the right side here, we're going to make a little thing like this. And x is the thing you always get to choose. You always get to choose your x's. And the easiest x is at random to choose. It could be minus 2 and minus 0. But we're going to take minus 1, 0, and 1. And then whenever I see x, I'm going to put a bracket in it. And I'm just going to replace it with the number I've chosen up top. So we get 2 times minus 1, minus 3. What's 2 times minus 1? Always go in bedmass order. Minus 2, minus 3 is minus 5. So put over minus 5 here. And 0 is a little easier because when it's 0, this whole thing will just disappear. And I'm left with minus 3. And then finally, when I put in 1, 2 times 1 is 2, minus 3 is minus 1. And boom. And actually, I only need two points. So then you should pull up graph paper for this so each square is accurate. And then you just find on the graph paper one of the points, minus 1, minus 5, let's say is down here. And then you find any other point, 1, comma, minus 1 right here. And you can even do 0, comma, minus 3. And you want to label them on your graph to get full marks. And then you just draw a line straight through it with your ruler. And more like that. And that's how you graph anything. Doesn't matter what the formula is. Graph each circle. So you have to understand that these are formulas for a circle. And the secret here is that the radius will be right there. The radius squared is the formula circle. So it's clear this radius is 3. So all I have to do is go up, take a Cartesian, put a dot 3. That's 3 away from 0. So that's going to be 0, comma 3. 3, comma 0. That's 3 away from origin. Down here is minus 0, comma minus 3. And over here is minus 3, comma 0. And then I just kind of join them with a circle and try to make it, match. And there. And then you just label your 3 points and even put the formula above your drawing. What about this one here? It looks complicated, doesn't it? Well, we can divide. We notice instantly there's a 3 in common with each. So if we divide everything by 3 on the left and everything by 3 on the right, it's clear that the right becomes 4. What does the left become? Well, a rule of fractions is when it's written like this, I can also write it like this. This plus that. That's a rule of fractions. You can break it up like that. Because that's all fraction is you're making a common denominator. Well, it's clear it goes in like that, and these cancel here, and I'm left with x squared plus y squared is equal to 4. And as I told you, the formula for a circle is this is going to be the radius squared. What's the square root of 4? It's 2. Which means if I were to draw this, I'd do the same thing. I'm going to have 2, 0, 0, 2, minus 2, 0, and 0, minus 2, and then make a circle. So these are all skills you should still have. Parabola, you're going to have to remember what the formula of the 3 basic formulas, standard, vertex, and whatnot of a parabola from grade 10 math. So, and they even want you to label the vertex and the axis of symmetry. Well, fortunately, the axis of symmetry is always the same value as the x value of the vertex. Now, this is right there. That is vertex formula. The opposite of this 4, minus 4 is the x value of the vertex, and plus 2 is the y value. So the vertex of this will be minus 4, 2. And because it has a minus in front, it's facing downwards. And because I can see that this is minus 4, the axis of symmetry will be x is equal to minus 4, the same as the x value there. It's always the opposite x value here. And I'm not going to graph it. To graph it, you do the same thing. Take a value like 0, 1, and minus 1 for x, plot it out. You might end up on just this right side of the graph. So once you feel the vertex, maybe take minus 5 as the x, minus 4 you already know, and minus 3. So points on either side of this minus 4 will help you graph it. But it's the same graphing techniques. You make a t-table and you choose some. What about something like this? Well, when it's like this, there's no translation going on with x. So there's just 0 for the x, minus 6 for the y. There's a plus number in front of the x squared, so it's facing upwards. And the vertex will be 0, minus 6. And the axis of symmetry will be x is equal to 0. So the axis of symmetry happens to be the y-axis. What do you do for something like this one? Well, this one's the same rule. That's vertex formula format. So that means it's going to be 2, which is the opposite of minus 2, minus 1. That's the vertex. There's a positive in front, so it's facing up. And x is equal to 2 is the axis of symmetry. So go visit your vertexes. This one has no translation for the x, which means it goes through 0, there's a problem here. We've got plus 6x. I better go back and make sure the other ones didn't say plus 6x too. No, they didn't. So, what's in common with both these terms? I realize that I can factor out what? I can factor out a minus x, let's say. So, if I factor, why minus? Because I like having x positive in my bracket. If I divide the first one by minus x, I get x. And if I divide the second one, I get minus 6. Right there, that's no longer vertex format. That's factored format, which means the points where this thing crosses the x-axis are when x is 0. So it goes through 0, 0. And when x is plus 6. The axis of symmetry will always be halfway between these 2 points, which is 3, which means I know my axis of symmetry is x is equal to 3. By plugging in 3 into either of these formula, I get 3 squared and then a minus applied to it. I get minus 9 plus 6 times 3, 18, 9, which means the axis of symmetry is, the vertex is way up here at 3, 9. And because there's a minus in front of it, it is facing down, which makes sense because the axis of symmetry was up there and the x-intercepts are down there. This is factored format. Go back and rehash. List the transformations. I don't want to list them all. And in future, I might not do all of these. So if I look at these, the transformations are the only transformation is a vertical shift downwards by 2. That's what that minus 2 is. The only transformation here are y transformations. We've got a stretch by a factor of 4, and a 3 translation upwards by 3, and then a reflection in the x-axis is what that minus is. That's how you would do it. Anything affecting the y with a negative is a reflection of the x. Anything affecting the x as a negative is a reflection in the y. We've got a vertical compression by a factor of half, and then a downward shift by 4 units. And then we have a horizontal shift to the right by 1 unit. That's it. We have a vertical stretch by a factor of 2, a vertical shift upwards by 5, a reflection in the x-axis, and a horizontal shift 3 to the left. So it's always the opposite in there. Solve. So they want you to practice your factoring. What number multiplies out to 6 and adds up to minus 5? It's minus 2 minus 3. So those will be also, that means, so x minus 2, x minus 3 are the factors, which means 2, 0 and 3, 0 will be the x-intercepts. Over here, I've got to put the minus 70 to the one side. I don't believe I can simplify it. So just to remind you how to solve a complicated one, you have to look at what's in front of the x squared. And we see a 3, and my first thing is going to be moving that 70 value to the other side, and it's all going to be equal to 0. And it means that when I move a plus 70 from the right to the left, it's going to become a minus 70. And when we are doing factoring, we're finding two numbers that add, or that multiply out to a times c. What's my a? My a is 3. What's my c? Minus 70, which means I'm trying to find numbers that will multiply out to 270. Sorry, 210. What are they trying to add up to? Minus 5, which tells me these two numbers are going to be very close together. So I can already say that, oh well, 20 and 10 is a factor because they're very close. And I can see that that's more than 5 apart. It's 11. So I got to find two factors that are closer together than that. I can half this and double that, but that's going to get me farther apart. So if I look carefully, it's kind of hard to see factors, and when you can't, you got to use the quadratic equation if there's no factors. But I'm going to look a little bit more closely, and I'm going to say, okay, well, it's got to be higher than 10. 11 doesn't work. 12, 13, 14, 15 doesn't work. 16. So sometimes this is the only way you can find factors. So 210 and 1, 105 and 2. We can't really divide it by 5 after that. You get 21 and multiply by 5 and 10. And you can't really do much after that. You can find 5 and 42. So what I did is half that and double that. And then sometimes you got to say, what are the factors of 210? And I think in this case, we'll have to use the quadratic equation. And, oh, yeah, the closest we got is 14 and 15, which are just too close together. Now, you want to get used to the quadratic equation and doing it by hand. But notice also that there are calculators in here. Once you get comfortable with it, go ahead and use the calculators. But until you get comfortable with it, do it by hand. And also memorize the formula, which is right. Let's see if they show it right there. And the discriminant will tell you a lot. So always do the discriminant first, which is the stuff inside the square root there. Calculate, and we discover that, yes, indeed, it's a complicated answer. So the x-intercepts are 5.73515, 0, and minus 4.0, this, which means the factors, I would just represent it like that. Those are the roots. But if I was going to do it as factors, it would be this. And you wouldn't want to ever do this, but so that would be the factor version. All right, going back to it. And I'm not going to do that. So as you get into 1.1, they just discuss moving away from y and into a function format. So you're used to y is equal to like 2x plus 3 as a format. But let me show you an example. Let's say the cost of your cell phone is $100. And let's say you got to pay $20 per month after that, every time you use your cell phone. If I was going to figure out how much this costs you after 10 months, I would use this formula. Well, y is equal to the initial cost plus 20 times x, where x is each month. And that way, if let's say 10 was here, 10 months, I could tell you it's 200 plus 100. It's going to cost you 300 to use that phone for 10 months. But what you would do in functions is you do cost based on the month is equal to 100 plus 20 m. And this way you get terms or things that are more relevant to what you're looking for. So this just means cost based on what m I put into the formula is equal to 100 plus 20 times the months. So for instance, if I said what's the cost for 3 months, I would do this. What's 3 times 20? 60. What's 100 plus 60? The answer would be that. The cost for using this phone 3 months is 160. This becomes a much more dynamic way of phrasing problems instead of y is equal to x. But keep in mind that they're the same thing. It's just called function notation. You'll also have to learn about domain and some standard functions. Domain is all the possible x values, and all the possible y values are range. And you just got to get used to some functions. For instance, for parabolas, the domain is always x can be any real number, but the range is always limited by up from the y value of the vertex. So if this was 0 comma minus 3 down here, then the range of this parabola would be y is bigger or equal to minus 3, because nothing exists graph-wise below that point. So you got to get used to ranges and understanding what a range is and what's a function and a relation, and a lot of people have problems with that. So there's 3 ways you can determine if something's a function. If you can draw a vertical line straight down and it touches in more than one spot, it is not a function. So if I draw a vertical straight line through this parabola, it only touches the parabola in one spot. So it is a function, and that's called a vertical line test. That's the easiest way to determine it. But when you're working with determine if these are functions, well, that's a circle, so that's not going to be a function. This is a standard format for a parabola, so that's going to be a function. And this is the standard format for, that's a slope-intercept format for a line. Lines are functions. So you're going to learn that all polynomials are functions. But then it gets you to figure out when something's a function based on numbers. And you got to get used to this idea. It's really annoying. It's not annoying, but it's complicated. So I'm going to also get used to this formula here, desmos.com. Very useful. And I'm just going to make every step by 1 and 1. And just copy that. If I have a piece of graph paper, and I determine 2x has a 4 up here, but 2 also has a minus 3 up here, I will immediately say this is not a function because it does not pass the vertical line test. It goes through those 2 dots. So whenever you see a 2x, or any x value that has this 2 different y values, it's not going to be a function. Not true for y values. I can have a 2 that reaches 4y here, and I can have a 5 over here that reaches a 4y here. That's fine. I'm repeating y's of 4, but these are 2 different x values, and it's clear if I draw a line through this and a line through that, these 2 dots count as a function. So that's a little trickier. I'm going to get you to read through it more. So check your understanding. These are the rules. So we're going to we're going to look for 2 x values that repeat. Minus 5, minus 3, minus 1. These are ordered pairs, which can still be a function. And 1. Well, I didn't see any x values that repeat, so right away I know that's a function. Right here I see minus 1 is the only thing that has a y of minus 3, but this 1 leads to both minus 3 and 0. If I were to graph that on my paper, I'd say, okay, well that 3, I think it was a 3, No, that 1 leads to minus 3 and 0. So at x is 1, it leads to minus 3. And so I put a dot there, and 0. Well, it's clear that won't pass the vertical line test. So that can't be a function. So whenever I see an x like that, that's leading to 1x is leading to 2 different y's, it is not a function. Not true down here. This 3 and this 5 both lead to this y of 2. That's fine. Okay, the easiest way for these is spot x's that repeat. 0, 3, 5. Oh, I got a 0 here. Now all I have to do is check to see if they're different y values. 4 and 1. So that is not a function. I have the same x value of 0 leading to 2 separate y values. Well, minus 4 leads to 1, that's fine. Minus 2 leads to 1, that's fine. 2 leads to 1, that's fine. 5 leads to 6. Notice none of the x values repeated, so I didn't even have to check that one. Use a ruler for these. Okay. Like I said, the vertical line test is the easiest test of all. Okay. You might say to yourself, well, this one is going to pass the vertical line test. And actually, I should probably do that. I should probably do this. There we go. That makes it a bit better. But if you notice right here, this line here goes through these 3 dots, so it's not a function. This, obviously, a circle is never a function, so nope. This sideways parabola is also not a function. This, however, only goes through this graph in one spot, is indeed a function. This is a parabola, it's always a function. And this sideways absolute value cuts through in 2 spots, so it's not a function. Vertical line test is very easy. Substitute minus 6 in each equation and solve for y. Use your results to explain why this is a function and that is not. Okay. I think I would rather figure out the graphs. That's my personal preference. But I get what they're doing. Okay, so how do I figure this out? So if I look at this function, x squared minus 5x, I can immediately tell that's a parabola. So I don't even have to worry about it. But if I put minus 6 in here and square it, I get 36. And minus 5 times minus 6 produces plus 30, which means minus 6 comma 70, so 66. Now that doesn't really tell me anything, except that I know that it's a parabola. Now over here, if I put minus 6 in, I get 36. Oh, you got to be careful because we're putting it in for x, and I'll show you why that doesn't work for this one. And it's hard to figure out what kind of graph this is. But if I put the minus 6 over here, I got a problem. So how can I solve on the right? I can't really, so let's put this x to the other side. So I'm going to get y squared minus 5y, and then minus x is equal to 0, and right away I can say there's a problem. Let's try instead to solve for y on the left. I can suck out a y and I get y minus 5 is equal to x. Now, if I were to pretend that was a x is on the left, I would quickly say, well, this is a parabola. And if this is a y on the right, I quickly say that's a parabola. Not a problem here. But by swapping out the y's, I immediately know this is a sideways parabola because I've inversed it by switching the x's and y's. That tells me that this is not going to be a function. So let's make sure that x is equal to y squared minus 5y. Sure enough, it is a sideways parabola, and I could tell that by first swapping the x's and y's, realizing it is a parabola if they're swapped. Therefore, when I swap it, it creates the inverse, and the inverses always kind of fall sideways. A little bit of knowledge. I don't think this minus 6 is relevant at all because it's hard to see how it solves. Except that you can't really come up with a square root that produces a minus 6. And even looking at the graph, if I look, minus 6 exists here and exists here. So it'll be tough to solve it. I'm trying to figure out how I would solve it for y, just knowing that. I know how you would solve it. My bad. So you put minus 6 on the left, and then you bring it over to the right, so you get y squared minus 5y plus 6 is equal to 0. And then when we solve this, we get y minus 1 and y, doesn't work, y minus 6 and y plus 1, which tells me there's two y values that can exist for this minus 6x value. If there's two y values for one x value, it's not a function. Sorry about that little bump in the road. Yeah, this is just an exercise of mapping, so I'm not going to do that. Then graph number 4, no, I'm not going to do that. Describe the graphs of the relationship. Okay, y is equal to 3 is a horizontal line, and x is equal to 3 is a vertical line. Plug them into Desmos to see. And vertical lines are never functions, and horizontal lines are. So y is equal to 3 is a function, and x is equal to 3 is not. So identify all these and determine whether it's a function or not. Fair enough. Make it a bit bigger. Crop it. Okay, what's this first one? It's clear this is a line. It just happens to be in the wrong order, but it's slope-intercept. I can put this here, and this here is a plus 5. So I just put plus here. And there. That's communicative property. You can always rearrange things that are adding together in any order you want. That's because 5 plus 7 is the same as 7 plus 5. Doesn't matter what order I put these in, they will add up the same way. So this is clearly a line. And lines are functions. What about this one? Well, I can already say that's a parabola. It's got an x squared with a downward shift of 3 and a horizontal stretch of 2. That's facing upwards, so it's a parabola. What about this one? This is still a parabola, but now it's in vertex format. And the vertex of this one is minus 3 comma 1. So it's the opposite of plus 3, and then just plus 1. And this minus means it's facing downwards, but it's a parabola. And I can already tell that's a circle. So that's the standard thing. When you see x squared plus y squared is equal to a number, it's a circle, which is not a function. So the first three were functions. And we'll just do what they say. And this is just to get you stretching about your knowledge of functions, right? All right. So just looking at the first one, this is a standard format of a line, so it's a function. If I put x into it, all I'm going to find is the y-intercept. So x is equal to 0. And then so if 0 here, that means 4y is equal to 5, so y is equal to 5 over 4. So the point on here will be 0, comma 5 over 4, and that's the y-intercept. If I put minus 2 over here, I get minus 6. Bring it to the other side, I get 4y is equal to 11, which means y is equal to 11 over 4. So it's just plugging it in. This is what is this? This is going to be a parabola. So the answer to this is yes, that's a function. What's this one? Clearly a circle. And when x is 0, y is going to be either 2 or minus 2. That's because when you take a square root of both sides here to solve, and you're left with the square root of y squared is just y, you have on the left, when you take a square root of something, you have to consider that the answer is either plus 2 or minus 2. And that's because if I square minus 2, I get 4. So if I had minus 2 here, it would still be 4. And if I square 2, it would still be 4. So there's two possible answers, which also tells me right away that's a circle. Or not a function, because it's one y produced one x value produced two different y values. So it's not a function, and they just happen to be right over top one another. I'm not going to bother for minus 2, just plug it in. You'll find that for minus 2 in the circle, y is 0. And so that's not a function. This one is a function. It's just a parabola that's rearranged. When x is 0, y is 2. So we've got 0, 2, which happens to be the vertex. So let's just rearrange it. I'm going to bring minus x squared to the other side, plus 2. So there's that vertex that I said would exist, 0, 2. Notice that when x is 0, this is also a downwards facing parabola because it's minus x squared. When x is 0, you're always going to find in this situation, you're always going to find the y. Okay, and I'm not going to bother with minus 2. What's this? This is, obviously, we've switched it around, right? It's no longer y is equal to x squared. It's x going to be equal to y squared, which means this is a sideways parabola again. And if I rearrange it, I get y squared is equal to minus x. When x is 0, y is 0, so it seems like that's normal, but it's actually the vertex. And you might say, oh, it's just one dot. But if I continue on and take minus 2 for x, so remember, put bracket minus 2. What's minus minus? It's plus 2. So I get y squared is equal to plus 2. Let's get rid of all this. Let's do it normally. So what I have here is y squared is equal to minus x. And don't forget it's squared. When I put minus 2 in there, got to remember to put a bracket around the x. That comes plus 2. And then when I take the square root of both sides, I get a possible y answer of minus square root of 2 and positive square root of 2, which means I produce two y values from the same x value of minus 2, which means it's not a function. It automatically tells me that it's a sideways parabola, and the only reason I got one value the first time is because that happened to be the vertex of the sideways parabola. And how would I verify the answers? Well, you could graph it, or you could do what we just did, find two values of x, or you could just recognize what the equations are as you get better. Determine which of these are a function, number 9. You can also just plug it into Desmos and study your, I would strongly recommend you study your parent functions, and I'll try to leave a link to the parent functions. This, you might say, oh, well, that's the same as y squared is equal to x, but it's not. This is just half a sideways parabola. If I were to graph that over here, it would look roughly like this in red. Actually, I should get rid of all that stuff. Roughly like that. And if I look carefully at it, I can see that, what can I see? So I think it was translated 2 to the left. So it actually starts right here, and it'll go like that. And if you know the original points, you can just subtract 2 from the x values, and you can plot a couple points, and you'll get marks for graph. But that is indeed a function, and you can always confirm in Desmos. So in Desmos, you just put it as is. And look at that. Oh, you got to hit home. Oh, you got to hit y here, by the way. And then if you hit home, you'll see, yeah, it's half of a sideways parabola. And you just get used to spotting them. All right, so that one's this one. What about this b here? Well, that's just a badly written slope-intercept of a line. And all lines are functions. It should be written like this. And it's got a slope of -1, and the y-intercept is 0, 2. It's a line. What about this? Well, I see x squared and y squared, and actually when they're subtracted like that, you might think it's a circle. But when they're subtracted like this, it creates something called, I think it's called a hyperbolic, and it looks like that. And it's well worth drawing, but they are not functions. So you'll get used to when it's x squared plus or minus, they are not functions. So let's try that. There you go. You actually end up studying these a lot in physics and in university. Not a lot, but a little bit. gets pretty bizarre. So it's good just to know whenever it's x squared and y squared in an equation, it will not be a function. What about this one? This is clearly a parabola whose vertex is -2, comma -4, the opposite of this and the exact version of that. And with this minus, it faces downwards. And use numeric graphing representations to investigate whether this is a function. Oh, we already did. Anything with the y squared is not going to be a function. And you just punch it into Desmos. X minus y squared equals 2. So, sideways parabola. All you do is punch in a few values of x. 0, we'll discover 0 doesn't exist, so the only time x exists is when it's bigger than 2. You could even put this y squared to the other. This is how it would be properly phrased. Okay, and it's clear that x values below 2 can't exist because you can't square root a negative number. If I had 1 here, it would be 1 minus 2. I'd have a negative number, and I can't square root it. So only values 2 and above can exist, which makes sense when you see it. And so I would put in 3 and figure out a couple y values, and I'd quickly discover for something like 6, right, the answer is going to be 4. And I'd discover that 4 has 2 values. One here, as soon as I zoom in a bit, which I can't quite get. Well, you can also always do it like this. Yeah, hang on. Let's just see if I can zoom in. I quickly discover 4. What happens if I put it? Let's just put a 6 in there and see what happens. I discover that these are the two possible values here. For y is going to be at the 2, so it's going to be 4 comma 2, or 4 comma minus 2. So there's two possible y values, which tells me there's no possible way that's a function. All right, determine which of the following relationships are functions. It all depends if you can determine y based on what happens to x. If you can just determine one y. And I'm not good at what's a function. If your earnings and sales, if he earns $400 per week plus 5%, yeah, that's because I can figure out how much Owen earns if I know how many weeks or sales he's done. As long as I can figure out how much he earns based on some information, it's a function. The relationship between distance and time, if Bran walks 15 kilometers an hour, yes, Bran walks 15 kilometers every 1 hour. That's what that means. So that means his slope is 5 up based on 1 hour. So you'd see a 5 increase based on 1. You'd see a triangle like that and a straight line. Because speed is constant. When you're in your car going 100 kilometers an hour, it's a constant speed, which means it's a line with a constant. The relationship between student ages and the number of credits earned, which is absolutely ridiculous. Just imagine if I said, okay, Brandon is 12. How many credits has he earned? You'll realize how stupid a question that is. And therefore not a function. Looking at number 12, the cost of renting this car. So always go to your questions so you don't waste too much time. What are the domain and range of this relationship? Well, in real life situations, you'll discover there's no negatives. There's no negatives. It starts here, which happens to be an x of 0, and seems to go on forever. So that means x is bigger or equal to 0. It also starts here at a specific spot on the y graph, right there, which appears to be 45, and goes up, which means y is bigger or equal to 45. So that's the range, and that's the domain. And you'd say XER, YER. Explain why the domain and range have a lower limit. Well, because we're in real time, and I can't have a negative distance that this car is driving. There's no such thing as driving the car negative 40 kilometers, and there's also no possibility of having negative $20. Is the relationship a function? Yeah, of course it is. It's a straight line. Sketch a graph. Oh, these things are stupid. All right. I mean, I might not sketch this graph, just so you know. And I'm certainly skipping number 14 rather. Okay, so sketch a graph who has a set of integers and its domain and all integers less than 5, then the 5 has its range. So I guess it never goes above 5, so I guess you can just do anything that passes the vertical line test and never goes above y is equal to 5. Sketch a graph of a relation that is not a function that has the same set of real numbers less than 10. Why? So it would just be anything that fits within the rules that it crosses. Ugh. And no, some stuff where in a lot of this, I'm going to do the practical number answers. A freight delivery company charges $4 per kilogram for any order less than 100 kilograms and $3.50 for any order more. Why must this relationship be a function? Because if I'm going to bring in a weighted package and you tell me, well, sir, it's $4 or $3.50, I'm going to say, what? Which is it, $4 or $3.50? I guess I'll choose the lowest cost. Obviously, when you bring something to the post office, they're going to tell you a precise price. So they must have a function system in order to tell you the precise price. This is called a time piecewise function. So if I were to try to fit this on a graph, I don't know if I can just sneak a graph over here. And I was trying to say, okay, well, it's $3.50 per kilogram. So it's 0, it's 0. And then every kilogram it goes up to $3.50, right? Like this. And let's say 100 was somewhere on this chart. Let's just say it's up to 2 kilograms. So at 2 kilograms, and then all of a sudden anything more than that is going to cost less, right? Because it goes from $4 for less than 100 kilograms and $3.50. So all I'm going to have then is a straight line that's going to have a slightly lower slope. So it's going to be a steeper cost for things less than 100 and then a slightly less cost. And then since it's less than, for the $4, less than anything 100 and higher will be included in this part of the graph. So you'd have a dot solid that represented the higher cost and a dot hollow at the same spot that's connected with this one. We'll get more into that. Graph the function, I kind of did, but if you want to see it, you would do it like this. You'd have to draw two functions. So one is going to be y is equal to $4 times x, right? But only for when x, 0 is smaller, equal to x, which is smaller than 100. And then you'd have y is equal to 350x, but only for when x is bigger or equal to 100. And then if you look, you'll see that these two graphs, when we hit 100, or actually when we hit 100 kilograms right there, and actually we should have connected. Oh no, it'll still work. So actually you're better off. You can see you're paying more here. Once you hit 87.9 kilograms, you are actually better off to add another 13 kilograms because anything from here on costs you more than this. So they should actually have connected those two. They shouldn't have done it like this. You'd actually never have a system like this. And notice there's going to be a hole on the blue line because we did not include the 100. There's going to be a solid on the 100 down here because it's included in the green line. Because if this was included in this one and this was included in this one, we would not be a function anymore because I'd have two y values that exist for 100x. But actually, post office would never do this because everybody, once they reached 90 kilograms, would just simply add in, let's see how much, they'd add in anywhere up to 25 kilograms and still pay less down here. So these should really be more. So I should actually be adding, this is 350, I should actually be adding 50 to this. So they connect. So the post office should be charging $3.50 per anything over 100 kilograms plus $50, because otherwise everybody would constantly be looking at that inequality of price, and they would be As soon as they hit this value, they would say, I'm gonna just add more weight to my package and pay less. Because if I have a 100 kilogram package, I'm paying $350. But if I have a 88.7 kilogram package, I'm paying $354. Why wouldn't I just throw 12 more kilograms in and pay less? So this post office would never do this. So I'd have to go back and make sure this question is, yeah, post office would never do this. There, right there, better pricing structure. Support my answer. Yeah, nobody's going to pay more for a lighter package. That's just that. So that's 1.1. And there you go. It's more about getting warmed up.